Hello and welcome to my final embryology video that is going to be a test yourself video for Colloquium 2. Now this acts as a demo or a mock colloquium for the practical part of Embryology Colloquium 2, meaning that I'm going to show you guys structures and slides without telling you what it is, allowing you to guess what structures they are, and then we can go through the answers one by one and see how many points you would have theoretically gotten. Obviously, these structures might not be updated for your current format for during the time that you're taking the course, for example, so do double check that with your professors, and that is hopefully the last time I'm gonna say that. Now for how this test yourself video works. First of all, I'd like to ask you guys to make a list of the numbers between 1 through 10. And within these numbers, you'll have to write in the slide name as well as the specific structure that I'm gonna show you for that specific number. We're gonna have 4 of these lists in total because there's 4 tests. Now for each number, we're gonna spend around 1 minute. So that means I'm gonna show you a slide and then I'm gonna zoom in to a part of the slide and then show you a specific structure within that zoomed in part that you also have to name within the number, right? And all within the span of 1 minute. So for 10 structures, it's going to be around a 10-minute test. And we're going to repeat that 4 times. As soon as we're done with the first test, we're going to go through the answers really quick for anybody who wants to do like a speed round and doesn't want to hear any explanations behind the answers. Just want to test themselves generally and move on, right? As soon as we go through the answers really quick, we're going to go through the answers again, but this time in depth. I'm going to show you what signs to look out for. I'm going to show you other structures that are equally as important for that specific slide. Structures I didn't manage to include in these 4 tests because it would be such a long video and I don't have the time to do that. I'm so sorry. But as soon as we're done with all of those 4 tests, I'm also going to go through a list of structures and a list of names for all the structures from each class that we went through, and there you'll be able to see which structures I've actually managed to include in these tests and which I haven't. So again, stage 1 of the test would be going through all of the slides 1 through 10 without giving you the answers, letting you guess. That would be the guess stage. Stage 2 of the test is going through the answers but really quickly, whilst stage 3 of the test will be going through the answers but really in depth and showing you exactly what to look out for, which other structures are equally as important, etc. And this will all be done 4 times over. Please make sense. So, without any further ado, let's start the very first test. Okay, the timer has started for the very first test. Now this would be the first slide we're seeing. And then going towards the bottom right area, we see this. So this is all within one and the same slide. I'd like you guys to tell me once we zoom in, like so, what the name of this structure is called. So both the slide name as well as the structure name, please. Got a nice ambiance going here with the motors in the back. Okay, next slide is another zoomed in version. And here we're going to see this first. And then we're going towards the left upper side. So please pay attention to where we are. Write down the slide name. And now we're zooming in towards this general area. And we see this. And then going towards this area, I know it's a little bit wonky, but bear with me. We see this. Once we zoom in, we see something like this. Please write down the name for this structure. Okay, next slide. We're in the same area, so we're going to see exactly the same slide and the same area. So the same slide name that you wrote in the previous number, which would be 1.2, write it for 1.3 as well. Zooming in, we see the same type of area that we saw for the structure before. And now we see this, again, same structure area where we were before, but now new structure instead. And I'd like you guys to tell me the name of this structure. So slide name the same, just new structure. Okay, next slide. We see this. Please write down the name of this slide. Okay, let's now zoom in. I'd like you guys to tell me the name of this structure. I know it's hard because it's not super zoomed in, but it should, or you should be able to identify it nonetheless. Okay. Next slide, we're on 1.5, we see this. And then zoomed in, we see something like this. Now please write down the slide name before we zoom in any further. Now we go towards the top part of this slide and we see something like this. Please write down the name of this structure. All right, going on to the next slide, we see this. Please write down the name for this slide. Okay, now we're zooming in towards this general area. We see something like this. Please write down the name of this structure. Okay. Next up, we have these slides. Now these slides are separate. They're not involved in a larger slide. I think that's fair to say since we can't really move around given that these are images. Then we go towards the right and we zoom into this. And we see this. Please write down the name of this structure. Next up is this slide. If you know already, please write down the slide name. Now we're going towards the bottom of this slide, and we see something like this. Please write down the name, once we zoom in, of this structure. I know it's a little bit hard since we can't really zoom in and it's not a good quality image. Hopefully it makes sense though. Okay. Next slide. We're starting here. This is number 1.9. So we're going towards the top left of this slide. Continuing on, and we see something like this. So again, top left of that slide. And we're zooming in towards this area. You can see something like this. So please write down the name of this structure. Okay. Next up is one that we should be familiar with by now. So please write down the slide name. Now we're going towards the top part of this slide, and we see something like this. Please write down the structure name for this thing. And this would be the last structure and slide name before we go through the answers real quick, in depth, and then move on with the second test. And if you find the time to do so, review your answers. Make sure that you're not forgetting a keyword. Okay, that's the end of this first test. Now let's go through the answers real quick. So the very first slide name was head development of dog embryo. It's okay if you don't know the exact animal. I think it would be enough to just write embryo head development. Zooming in, we were zooming into the eye. And this was the neural retina because this was the area that I was showing you guys. Next up, the slide name was the total embryo in sagittal cut. And you can add in the age if the professor requests you to do so. And then in high magnification, we were looking at the liver and specifically the megakaryocyte of the liver. Next slide is the same total embryo and sagittal section, like I said. And then we were still in the liver, but now we were looking at the blood vessel, differentiated blood vessel, if the professor asks you to write that. Next slide is the developing tongue, 6 to 7 weeks. You have to write in the age. And then for the structure, it was a blood vessel. 1.5 slide name was the small intestine development. And then the structure was the inner circular layer of muscularis externa. I would have personally written muscularis externa. And then 1.6 is the eye development. The structure is the proliferating epithelium. 1.7 is the developing adrenal gland and metanephroslide. And then the structure is the fetal cortex. 1.8 is the developing tongue, 6 to 7 weeks. Again, just a new image. And then for the structure, it was the fragment of Meckel's cartilage. It's enough to write in apoptotic Meckel's cartilage as well. And then we have the sagittal section of the human embryo brain. And then zooming in, we had the developing pons. Final was the developing eye. We had this before, and then zooming in was the ciliary process, or developing ciliary process. Now we're going through all of these structures more in detail and in depth to show you which symbols, signifiers, and what other structures you have to look out for that I didn't include or did include in this specific test. Now, number one, this is a slide that we actually have in e-studies. It's just upside down and segmented because sometimes you won't get to see the entire slide, but more often than not they'll actually show you the entire head in smaller sections, but these are the most important part for me. First of all, I'd like you guys to identify the late tooth development. As soon as you see that with a characteristic blue dentin, you know for sure you're probably in a animal head, right? And then you can also see the developing tongue here as well. The eye is very, very identifiable in almost every slide and structure. Only here it looks a little bit wonky, and that's why I picked it out. So once zoomed in, you can see it here. And of course, the neural retina looks, again, a little bit segmented and not as characteristic as we usually like it to be, but it's still the neural retina, and it still could be a structure that they bring forth. This would be the vitreous body. We have the pigment retina right here. Let me see, and yeah, that's it for this specific eye. We also have the intraretinal space right there. Next slide is a part of the total embryo and sagittal section, and like I said, this is one of the most characteristic organs of the total embryo and sagittal section because it's the darkest organ we can see, and this is the thymus. And the developing thymus, either you go towards the right or upper part of the embryo to see the head, or you go lower to see the heart, the remaining part of the thorax, or the abdominal region. And I hope you saw that signifier of a diaphragm that separates the thorax from the abdomen. Another little Easter egg that I hope you guys noticed are the ribs. So you can see there the ribs are here, and you can't really see them. They should end here. Obviously you can't really see that now, but this is the section where the ribs are. So obviously they wouldn't continue here, right? And that is also another signifier that this is the thoracical region. Zooming into the liver, here we actually had the pancreas, and this was the liver. So sometimes they show you a little bit of the abdomen in its totality before showing you the actual organ that they're interested about. And then this is what it looks like zoomed out, and then zooming further in, we have the megakaryocyte here. It's a fairly hard cell to find inside of the liver, so it might not pop up in the colloquium due to the fact that it's so difficult to find. However, if it wasn't this, it could have been a nucleated erythroblast or a differentiated hepatocyte that could have popped up as well. And that brings us to the next slide and structure. Same slide and same even tissue that we're in. We're still in the liver. But instead of looking at the megakaryocyte, we're actually looking at this thing right here. And this is a blood vessel. A lot of the times, professor likes to fool you or to trick you into thinking that this is a more advanced structure that you've been actually studying for, or you've recently learned about in this colloquium. But in reality, it's just a very common blood vessel. And that's, they like to spice it up like that. A lot of people could have made the mistake of writing hematopoietic islands here, but this is a blood vessel because we can see the blood vessel wall. The hematopoietic islands would be all of these darker dots because they consist of these really immature nucleated erythroblasts compared to the mature ones which have all of these beautiful pink cytoplasm. So that is the difference here, and that is a common mistake a lot of people make, thinking that a blood vessel would not be the answer here, when it in fact is. Next up is the tongue. This one is almost perfect for under the microscope because you can actually see it in its totality, and an important thing here was that it was 6 to 7 weeks. Why? Because if we look at most of the part of the tongue, not this part, but most of the majority part of the tongue, it's smooth, it's even, it doesn't have those characteristic papilla that we know that the tongue has in general, right? Instead, if it's this smooth, now let's again ignore this part. If the majority of it is smooth, then it's 6 to 7 weeks old. If it's not smooth and most of it have these papilla protrusions coming out, like here, then it would be 11 to 12-week-old tongue. And also you have to write in the developing before the actual slide, or else you lose the points. Magnified, here we have the blood vessel. Again, we had a blood vessel here and we had a blood vessel here. They might as well have done that for you guys twice, right? This is just me trying to simulate that experience that you might have in the colloquium. So here, a lot of people would have assumed that we're going to talk about the sublingual glands, right? But instead, they're talking about the blood vessel. Again, trying to trick you, trying to make you think that you're wrong for writing two of the same structures twice, but sometimes it could, just be as simple as that. And also, if I know some of you would assume that it's hard to identify this as a blood vessel, but see how thin the walls are here, and then compare that with a gland. Yeah, that's definitely a blood vessel without even having to zoom in. And it's surrounded by mesenchyme. Here we have the small intestinal development, probably one of the most iconic slides out there, most identifiable ones. And then once zoomed in, yes, I would have written only the muscularis externa. I wouldn't even have written the inner circular layer, but it all depends on the professor that you have. I know Professor Vivads wants you to specify which part it is. This would be the outer circular layer of the muscularis externa, and this would be the inner circular layer of the muscularis externa. Again, personally, I would have just written muscularis externa, but depending on the professor, I might have not gotten full points. Full points would have been this. And another thing, the villi here, we do have them, developing villi. We have the submucosa here, and then we have the tunica serosa underneath the muscularis externa. Here we have the developing eye, again, probably one of the most recognizable structures due to the massive lens that we have here, but we're looking at the eyelid instead, and we're seeing this proliferating epithelium. Again, this is not a structure that always appears for the developing eye. It might not appear at all for the developing eye slides in some slides that we have in e-studies, right? But if we do have these eyelids, which we know are eyelids because, again, these hair follicles being eyelashes, right? And we can see this almost glue that keeps both the upper eyelid and the lower eyelid together, then we know that it's the proliferating epithelium. Here they could also ask you about the conjunctival epithelium. They could ask you about the skin, the epidermis, the dermis. They can also ask you about one of the most important structures of this colloquium, which is the M. orbicularis oculi, which is this muscle within the center of an eyelid. But in this case, I only asked you about this part. Okay, these are separated adrenal gland and metanephros structures for this slide. And here we can actually see no clear medulla. Even though there's a light center, this seems to be a weird cut, so we get a lot of the cortex still within the center. We should honestly only have mesenchyme here, none of these other structures in the center, if this was truly the medulla. But here we could definitely ask you about the differentiation of nephron. We could ask you about the renal corpuscle, the metanephrogenic blastema cells. We can ask you about the neural crest cells that we very detailed see here as well. But instead I asked you about the fetal cortex, right? There we go, the fetal cortex. I didn't ask you about the secondary cortex up here. I asked you about the fetal or the primary cortex down here. But the neural crest cells could also be a really good question for this specific structure. Next up, we have the developing tongue 6 to 7 weeks again. However, this is a different slide, so we have to see it more zoomed in. And here we see how smooth that tongue is on the surface. No papilla at all, so we can very clearly identify it as a 6 to 7 week old tongue. We have all of this skeletal striated muscle tissue, but instead we're actually focused on these slides. Further down, we can see this structure. And this structure is actually a hyaline cartilage on the verge of fragmenting upon itself. So it's like killing itself, pretty much. It's getting rid of itself. That's why we have the apoptotic/fragment adjective before the Meckel's cartilage to describe it. Again, if we see a hyaline cartilage-like structure underneath the tongue within the lower jaw, the only two bony or ossification structures that we really can see is either the intramembranous of ossification, which does not look like this, let me tell you that. It looks more like a zebra pattern or zebra stripy pattern. Or we can see a hyaline cartilage-like structure, which is the Meckel's cartilage, if it's within the lower jaw. And we know that this is hyaline cartilage because we can see all of these hypertrophic chondrocytes as well. Of course, we have other structures here important as well, but we'll get to that in a later part. Okay, this is another slide that we have. Again, we start off by showing you the eye. The eye is one of the most important signifiers for brain development because they want you to see that we're positioned within the head. So if we see the eye, you can immediately say, okay, we're in the head. Now let's look at the other structures within the head. We had the inner ear development here, but further down, close to the inner ear development, we have this little area. Zooming in, we can see something like this, right? This is still where we were, the inner ear development, but now we have this area instead. This, if you remember, looked like a little guy that was sitting down with the feet and the little knee, right? This would be the pons. This is the medulla oblongata, and this backside is the lamina quadrigeminea. So backside lamina quadrigeminea, it's just flipped, so it doesn't look like he's sitting down, but we can still see the characteristic like knee and foot shape here. The knee is the pons, and the lower legs are the medulla oblongata. We also have the plexus choroideus here. There could obviously be other structures that they ask you about. Here we have the neocortex, like I said, the plexus choroideus, the inner ear development, also nucleus caudatus and its derivative structures as well. But for now, we're looking at this specific area. Again, developing eye, but here we're looking at this part, like the vanilla bean pod. And like I said, the stem of the vanilla bean pod is the ciliary body, while these protrusions, these U-shaped branches that we have from the body, is the ciliary process. Watch me actually not spell ciliary with, okay, no, it's only one L, good. Unless I'm wrong. Okay, so again, the ciliary process are these protrusions out, while the ciliary body is the stem that holds it together. And this is the developing cornea. We have the conjunctival sac / eyelid space. We have the anterior eye chamber, the posterior eye chamber. We even have the degenerative membrana pupillare here as well, a little bit of the lens, a little bit of the anterior cuboidal epithelium, and then here we have those arteria hyaloidea that Professor Vaivads mentioned as well. And all of this is the vitreous body. Hope you've prepared a second sheet. Now we're going to go through this second test. The first structure and slide looks something like this. We going towards the right side to see something like this. Again, let's just make sure that we're getting everything. And then go further down and we see something like this. Now I'd like to zoom in on this general area. Here we go. Now going further into this area, we see something like this. And then zooming in, again, we see something like this. Please write down the structure name of this. So slide and structure name. Okay, next slide. We are in the same slide. So the same slide as previous, please write down the same name for both. But now we're going towards up. So previously we went towards the right, now we're going a little bit up. And we see this general area. And now we're going to zoom into this general area. And we see something like this. Whoop, pixelated, that's great. But zooming in, we can actually see something like this. Tell me the name of this structure. All right, next slide, we have this. Now going a little bit towards the right, we see this. And now I'm zooming in to show you guys this slide. And then zooming further in, we see something like this. Please write down the name of this structure. Could also be this structure. This fits smart. Okay, next slide. We see something like this. Write down the slide name. All right, zooming in, name of this area. Okay, next slide, we see this under the microscope, and then going further towards the left, we see this. Bottom left, I guess. And then more further towards the left, we see this. But we're going back towards this general area, and would like to zoom in and show you this. Please write down the name of this structure. So slide name and structure name, please. Okay, next slide. We're seeing this. Now we're going towards the upper left part, and we're seeing this area. And I'd like to zoom in on this part, and we see this. Okay. Now, please tell me what this structure is. All right. Next slide. We see something like this. This is further down, but we're going back up. We're zooming into this area. And you get to see this. Please write down the name of this structure. All right. Next slide. We see this. Please write down the slide name. I would like to zoom in towards this area-ish for us to see this. Please write down the structure name of this structure. Okay. Next slide looks something like this. So if you already know it, write down the name of this slide. We'd like to zoom into this slide and we see something like this. Please write down the name of this structure. This structure works as well. And for the final slide, we see something like this. Please write down the name of this slide. And we're going to zoom further down to see something like this. Zooming in, like so. Please write down the name for this structure. I am not living next to a highway, I swear to God. They just do that sometimes. Oop, that was the alarm. Okay, that was all for the second test. Now let's go through the answers real quick and in depth. Real quick, the answers for 2.1 for slide name was total embryo and sagittal section. The structure that we were looking at were the hematopoietic islands. I misspelled it, but we'll fix it. Hematopoietic. The next slide was the same. It was total embryo and sagittal section. And then for the structure, it was the brown adipose tissue. Okay, for the next slide, it was the developing hand. And for the structure, it was the apoptotic or hypertrophic periderm cell. 2.4 had the eye development as a slide, and for this structure, it was the conjunctival sac or eyelid space. 2.5 had transverse section of embryo, and the structure was the developing pleura. 2.6 had the slide name of head development of a dog embryo, and the structure was the developing enamel. 2.7 was the embryo in sagittal section, and then the structure was the developing spinal ganglion. 2.8 had the developing adrenal gland and metanephros. It would be enough to just write in metanephros here because we didn't really see the adrenal gland. And then for the structure, developing renal corpuscle. 2.9 was the developing tongue 11 to 12 weeks. And for the structure, it was the striated skeletal muscle fiber bundle. 2.10 was the same as previously. It was still the developing tongue 11 to 12 weeks. We're just looking at a different section of it because it was the interlobular duct of sublingual gland for the structure. There are like 10 other names for this structure, so, you know, if you know, you know. Okay, going into the answers more in depth now. All right, let's go through the structures. Now, like we said in the first test, we could see the thymus here, which is a very dark color and helps us recognize that we're in the upper thorax of the embryo. We can also see the developing ribs here as well. This would be the heart, only very segmented, and then we have the diaphragm, the lungs, and the liver right there. Zooming in, this would be a section where we can see the liver, we can see the pancreas, we can even see some sort of intestinal loop or recanalization happening there. But we're zooming yet again into the liver here. And now we're actually looking at the hematopoietic islands right there and right here. I showed you 2 examples of it. If you feel unsure about a specific structure, but you feel like if you saw it in another example of it, you would be more sure, ask your professor. I'm pretty sure they would let you or show you another example of that same structure within the same slide if it helps you and if you ask. 2.2, the same slide again, but now we're going up, not towards the right. And we see this. If you can recognize this as the developing vertebral column, you are on a good path because again, this is very helpful and insightful for all remaining structures, right? But we're looking at the back of the vertebral column. And what did I say about the back of the vertebral column? You can either find striated skeletal muscle fibers, or you'll find one of the more important structures of this colloquium, which is the brown adipose tissue. Now, I know this is very, very pixelated, but that's kind of just what it looks like once you zoom in. Even under the microscope, it looks this chaotic. But zooming further in, you can actually see all of the individual brown adipose cells with the lipid inclusions within. You can also see a white adipose cell just peeking through a little bit, scattered about in the brown adipose tissue. But that's how brown adipose tissue looks like. If you know that you're within the back of the vertebral column, it could either be skeletal striated muscle fibers, or it could be brown adipose tissue, or if they look at this area, which would be the developing skin. But all of those are very separate and don't look anything alike, right? This doesn't look like striated skeletal muscle fibers, and it doesn't look like the skin. So hopefully that narrows it down to brown adipose tissue, specifically this, right? Next up is the developing hand, and once zoomed in, we see something like this. So that would be the didymis and epididymis. Here, didymis region epidermis region, dermis region. And here we can't actually see the lymphatic vessels super clearly. We do see a blood vessel here because that looks like it has blood cells in it. But we do see a apoptotic and fairly large periderm cell right at the top of the epidermis. We can also see the basal membrane very clearly. Could be another structure added just to spice things up. We can see the mesenchyme that makes up the dermis, and we can see the blood vessels and some lymphatic vessels here as well. And the basal cell layer too. We can also see a flattened periderm cell right there. I would say that was the best example, maybe this thing as well. If you've only written the periderm cell, you won't get all the points because there's a difference between a flattened periderm cell and an apoptotic or hypertrophic periderm cell. Ask your professors which of these adjectives you have to use for the colloq. Next up is the eye development. We should be able to recognize this immediately by the lens. And then for this structure, it was the conjunctival sac. Now, I made the mistake of accidentally showing you guys this area before I moved on, so I tried to clip it. But in fact, this would be the anterior eye chamber. This is the conjunctival sac. So, you know, it's easy to make that mistake. So again, conjunctival sac or eyelid space, again, depends on the professor that asks you. And it's only the space between the cornea and the eyelid and cornea right there. Sometimes it doesn't even exist. It only exists when we can actually see the eyelid in front of the cornea. Next up is a very special section of the embryo, the transverse section. So imagine the embryo being cut in a cucumber. Here we can see this developing skin with the epidermis, the dermis, and follicles. It looks like this is some kind of animal embryo due to the fact of it having this many follicles. And then we can see the skeletal striated muscle fibers. We can also see this vertebral column right here with this spinal cord in the middle. And this could be something that they ask you about, even though I didn't in this case. Definitely a good example to show you all of the different layers of the spinal cord, the neural canal, the canal centralis, the pia mater, one vertebral column, what it looks like. This could be the dorsal aorta as well. They could ask you all about that as well. These are the lungs in pseudoglandular stage, which is what we're actually focusing on for this structure. And then we can also see the lung, which is to the left of the lung. We can see the liver, which is to the left of the lung, and the diaphragm right there as well, which is something that they can still ask you about. And here we can zoom in to show you the liver structures, but instead we're zooming in to show you the lung structures. And you have to write in the developing lung in pseudoglandular stage if this was a separate, if they asked you about the entire organ, but here they didn't, they asked you about this specific structure. And this is the pleura. It's like this loose tissue that surrounds the corner of the lung like so. We can also see blood vessels within the lung, which is another point of contention that is easy to mistake for other structures as well. Some students assume that these are bronchi if we can't see the characteristic red blood cells within. And of course, we have the smaller bronchioles in the center with the mesenchyme within. Here we have the head development of the embryo. We saw this before. We can see the characteristic eye shape with the neural retina within. We can see those teeth, and we are going to zoom into the teeth, but not those specific teeth, this specific teeth. Here we can still see some more tooth development. We can see the intramembranous ossification in this bright, beautiful blue, and we can see the tongue development as well with all of these striations making up all of the muscle fibers. But here we're zooming into this area instead, and we're seeing this. Now this almost looks like a Colgate toothpaste, right? We can see the blue and we can see the bright red enamel, and the blue is the dentin. This entire thing is the late tooth development. So they might ask you about the entire thing. They might ask you about the dentin instead of the enamel. They also might ask you about the intramembranous ossification that surrounds it. All of this area as well, the intramembranous ossification. 2.7 is the embryo and sagittal section, more common for colloquium 1, however still could be a structure mentioned in colloquium 2. This specific structure, I mean. So we have the vertebral column here. Again, if you don't recognize this as the vertebral column, study it. Study the shape, study the different variations of what you will see under the microscope. This you have to be able to identify like the back of your hand. We can also see a piece of the lung in pseudoglandular stage. We can see the developing adrenal gland here, the metanephros. We can see a little piece of the diaphragm here being broken off, because this is where the, if there were any, this is where the ribs would end. And we have the thorax region here, we have the abdomen region here, and we have that bordering diaphragm in between. And here, if you remember, we have the notochord, we have the intervertebral space, the vertebral columns made up of the hyaline cartilage, and we have all of those red cherry-shaped structures known as the developing spinal ganglion, still as important for colloquium 2 as for colloquium 1. Next up is the developing adrenal gland and metanephros. In this case, I said if you only wrote the developing metanephros, it would be enough because I didn't really show you the adrenal gland. Again, we're kind of limited with images here, but we zoomed in towards this general area, and I asked you about this structure or this structure, right? And like I said, if we see like a little ball that has that is next to a little white opening that looks like a crescent moon, right? Like a little moon, and the star being that big lump in the middle. This is the developing renal corpuscle. They could still ask you about the differentiation of nephron here, which is this. They can still ask you about the mesenchyme. They can ask you about the blood vessels, which is such an insignificant structure in comparison with all the other structures we have to learn about, because it's such a typical structure and such a basic structure, but still something that they can bring up just to test and see if you can differentiate a nephron from a blood vessel or a renal corpuscle from a blood vessel, and etc. And we can also see the metanephrogenic blastema cells here. If they zoom in, this would be the capsule of metanephros, I would say, and then this space could be the renal pelvis for some, for others not so much. But yeah, that was that structure and slide. Next up is the developing tongue in 11 to 12 weeks. Now we have this and we have this. These are the same structures. They're just taken from different angles and different cameras, right? But in this case, it's yellow so that we could match this image. And this is pink so that we can match this image. I'm about to sneeze. Okay. Now, like I said, it's either 6 to 7 weeks or it's 11 to 12 weeks. The 11 to 12 weeks, how we differentiate the ages is looking at the surface of the tongue. If we can see a lot of these papilla poking up, the developing papilla, then we know that it's an older tongue, and therefore we can definitely say it's an 11 to 12-week-old tongue. But if it's smooth and doesn't have a lot of those papilla, it would be a 6 to 7-week-old tongue. This is all skeletal striated muscle fiber, but we are zooming into the skeletal striated muscle fiber, and see how it looks like dots everywhere. That's because the tongue is such an intricate muscle. It has all of these networks of immature striated skeletal muscle fibers. So these are not immature, it could be mature. In this colloquium, it doesn't matter. You can write in a mature, you can write in immature. I would not use any of the adjectives. I would just write in striated skeletal muscle fibers. But here we can see the longitudinal cuts. We can see the cross-sectional cuts. Sometimes we can even see nerve fiber bundles here. So be careful there. This kind of looks like a nerve fiber bundle, and they can ask you about a nerve fiber bundle instead of asking you about a muscle fiber bundle. So make sure that you know the difference there. They can also ask you about the blood vessels, right? This is the exact same slide. We're just zooming further down towards the bottom, and we're seeing this. So that would be the end of the tongue and the beginning of the mesenhyme and the sublingual space. And if we're at the bottom of the tongue, these structures that we see here are all glands that are sublingual, right? Or the sublingual glands. Some professors accept the major salivary glands as an answer as well, but some want you to be very specific. And if we have glands, we can also sometimes have very large ducts. In this case, one of the largest ducts, the interlobular duct of a sublingual gland right there. There are other names for this. I do not remember them out the top of my head, but this was an acceptable answer for our colloquium at least. Okay, and then we have the mesenhyme that surrounds it. We have the blood vessels. Remember, sometimes they can trick you and show you a blood vessel instead of showing you a gland, just to see if you can differentiate between the two. They can also ask you about the oral epithelium. In this case, I would say those are the most important structures for this particular image. That's it. Now we can get into the third test. Okay, ready for the third test? Let's start the timer, and then let's start with the slide. So this is what we see at first, and then moving up towards the top left, we see something like this, and we zoom into that general area here. And then towards that left structure, we zoom in and see this. So it's a zoomed in version of this structure. And then the question is, what is this structure called? Maybe I should actually be using this instead. Don't forget to write in the slide name as well. All right, moving on to the next slide. We're within the same area. And then we move towards the bottom left, so same slide. And we zoom into that general structure. See something like this. So for here, I'd like you guys to write down the name of this structure. And also the slide name will be the same as before. No idea if that's a goose or a baby crying outside. Okay, next slide. Let me just start the clock all over again. We see something like this. Now moving towards the left side, it looks something like that. Then continuing on a little bit towards the top, we see something like that. And now we're going to zoom in. And this is what we see. And then zooming further in, we see something like this. So please write down the slide name and the structure name of this structure. All right, moving on towards the next slide. Let's see here. Here we go. This is what that slide looks like under the microscope. We're going to zoom in towards the bottom area here to see something like this. So slide name and the structure name of this part of the slide. If we zoom back, it would be something like this, if that makes more sense. Okay, next structure and slide looks something like this. So write down the slide name. And then zooming in onto this general area, we see this. Now please write down the structure name for this part. Right. Now for the next slide. We're on point 3.6. And this is the slide you're given. Zooming in, we see something like this. So write down the name of this structure. Oh, hello, Mio. Okay, next structure. Here we go. This is what the slide looks like zoomed out. And then zooming in, it looks something like this. I'd like you guys to write down the structure name for this area. I do realize it's a bit low quality and blurry, but this is what you get. Ooh, sorry, this. Okay, there we go. Now on to the next slide. We see this. We're going towards the bottom right part of the slide. And then a little bit towards the bottom left. So now, zooming into this area, we'll see something like this. Write down the structure name for this structure. Now on to the next slide. Here we go. This is what it looks like. So please write down the name for this slide. And then going towards the bottom lower half of the slide and zooming in, we see something like this. So in this case, I'd like you guys to write down the structure name for this area. Right. Now for the final slide of this test. This is what it looks like. Going back to that area we saw at first though. Zooming in, see this. So write down the structure name for this structure. Okay, that was all for the structures. Now let's go through the answers real quick. 3.1 slide name was the sagittal section of human embryo brain. I think head development would work as well. And then for the structure, it was the desmocranium. So this was the structure that was shown. For the next slide, it was the same as the previous one. So again, you can write it down brain or head. But for the structure, it was the neuroblast migration or migrating neuroblasts. So all of those. 3.3 had the structure or the slide rat embryo head in sagittal section. I don't think you need to be specific by writing which sort of animal it is, but I wrote it in just in case. And then for the structure, we showed you the developing hair follicle. 3.4, the slide name was the developing eye because we couldn't really see any other brain development or head development structures here. So it would be easy to just write in the developing eye. For the structure, it was the vitreous body. 3.5 is the embryo in sagittal section. You could also, since we couldn't really see other parts of the embryo, it's enough to just write maybe the developing vertebral column of embryo in sagittal section. Again, we couldn't really see any other structures, so that would be fine as well. And then 3.5 in high magnification, we saw the marginal zone. The slide name for this, because we couldn't see any other structures, was just the developing lung in pseudoglandular stage, not the total embryo. And then the structure was the dichotomous division. Next up is the developing finger, or finger development, and then for the high magnification, we saw the developing nail matrix. And then the next one was the head development of dog embryo. Again, you don't have to be specific with the animal, I don't think. And just in case, write it down if you do recognize this slide. And then for the structure, we had the brown adipose tissue. We didn't zoom in, but it definitely was the brown adipose tissue if you compared. You can go through it later. 3.9, developing tongue, 11 to 12 weeks. And then for the structure, it was the sublingual gland or major salivary gland, always depending on what the professor wants you to write. 3.10, the animal head in sagittal section. And then for the zoomed in version, we had the developing nasal mucosa. Now let's go through all of the answers more in detail. For 3.1 and 3.2, the important part here I wanted to show you guys is that beyond what we have in the human brain, There's a lot of other adjacent structures that are equally as important. So what could happen here is that they show you parts of the brain, and then they show you other structures surrounding the brain as well to stay on the same slide. So what I did here was that I showed you the general area of the human skull with the human brain development. We saw the inner ear, and we saw one of the most important telling signs of us being where we are, which is the human eye, or the developing eye. We have the orbital bone here, and then following that we have this forehead area. Now what I mean by forehead is that we're looking at the front area of the human skull. Now we have two different types of skull-related structures in this colloquium. We have the chondrocranium, which looks more like the hyaline cartilage, and it's towards the bottom slash back of the skull. And then we have the desmocranium, which looks more like almost like a bone trabecula, very dark and very segmented, I would say, and it's towards the front of the skull. In this case, I hope it makes sense to say that this would be more like the desmocranium and not the chondrocranium because of its segmented visual style, and because it's also towards the front area of the skull. We can still see the eye here, for example. Of course, they could ask you about the eye instead. They could ask you about the orbital bone. They could ask you about the areas of the brain instead, maybe even the skin parts. It all depends, but in this case, I wanted to show you guys the desmocranium. Going down, this was where we were. This is the desmocranium. It continues here as well, and we still have that eye. But then going towards the bottom, now we're actually looking at a part of the brain. And here we can see, if we zoom in here, actually we can see the nucleus caudatus. We can still see the migrating neuroblast, which was the structure that I asked you about, and as well as the capsula interna here as well. We can also see the plexus choroideus. Like I said, it looks very wavy, very frilly and light, and it's almost in every part of the brain that we're looking at. It could be above the capsula interna like we see here. But here we can see those migrating neuroblasts very clearly. There are some slides at the anatomicum where you can't see these migrating neuroblasts, so don't be scared that if they show you the nucleus caudatus area and you don't see the migrating neuroblasts, that it's not the nucleus caudatus. It all depends on the actual slide, but in this case we can actually see them. We can also see part of the neocortex, I would see here, part of the thalamus, as well as the plexus choroideus, like I said before. Here we have the rat embryo head in sagittal section. Like I said, it depends on if they want you to write in the animal that you're looking at. Maybe it's the dog, maybe it's a rat. It's up to the professor how specific they want you to be. But here, like I said before, one of the biggest tellers that you're in the head area, and we're not looking at the brain specifically, but just the sagittal head section, almost a symmetrical line down the middle of the head, we have the developing tongue. And in the tongue we have these striated skeletal muscle fibers, which is definitely something that might come up in the colloquium as a question that they ask you. They can also ask you about the blood vessels, just like casual, very simple structures to sort of try to throw you off. The oral epithelium, not as casual of a structure, but still something that could be asked. The same thing as that oral epithelium underneath the tongue. They can ask you about the tongue papilla. They can ask you about the nerve fibers that you can often find around the tongue here. This is the late tooth development, so we have the enamel and dentin there. In this case, we can also see that keratin at the top of the epiderm. But here, when zoomed in, we see those, I would say almost whiskers, but hair follicles is enough. So all of that and all of these smaller ones as well. Do we see the nose development? I'm gonna say no. We can see another late tooth development right there, but nothing else in this structure specifically. Of course, they can zoom in here, show you the epidermis, which is this darker area, not the red area, that's the keratin, but the darker area underneath the red area, which is the epiderm or developing epiderm, this is the developing dermis, and then they can show you the lymphatic vessel of the developing dermis as well. Okay, next structure. Here we see only the eye and nothing else. This is a separate slide of showing you only the eye. We also have the orbital bone here, I think, in the actual image, but you can't really see it here because I couldn't capture it that fast. But yes, we have this very large lens here with the long lens fibers and the anterior cuboidal epithelium that lines the front of this lens. Like I said, those could still be structures asked from you. We have the developing cornea here. We have the degenerative membrana pupillata here with the anterior eye chamber and the posterior eye chamber being behind it. And then we also have the nodal retina, the pigmented retina, which is this dark line, and then the ciliary body, and then the ciliary body processes, which are these U-shaped indents in the ciliary body itself. We also have the eyelids, so here we can ask, or they can ask you about the parts of the skin. And then we have some sort of nerve development. This is the optical nerve here. But instead, I zoomed in here towards this area, and then you guys were asked about this general part, which is the vitreous body. And the vitreous body have these degenerating blood vessels known as the arteria hyaloide. I believe that's how you spell it. Double check me. I did not have that structure in my colloquium, but I believe that's also something that they could ask you. And then we also have the intraretinal space. Then underneath here, we also have that pigmented epithelium. They can ask you about the choroid, which is directly underneath the pigmented epithelium, which has all of the blood vessels, or the developing sclera, which is a lot lighter part, which is underneath the choroid instead. And these are some muscles, I believe, muscle cells. Okay. Next part here, I did write down embryo and sagittal section. If I only got this in the colloquium, I think I would still write in embryo and sagittal section because I don't really know of any structure where we can only see the spinal or developing spinal cord and the developing vertebral column as well as those muscles and stuff. But since we could only see this image for your test, I think it would be enough to just write in like embryos, like vertebral column area with spinal cord, just to like try to gain all the points I could. But here what's important is noticing those striated skeletal muscle fibers as well as the vertebral column, because like I said, they could still ask you about those basic structures. And one of those basic structures is the spinal ganglion. So all of those dark areas you see are the spinal ganglion. We also have the pia mater, which is just floating around a little bit frilly like so. You can see it here as well. And then we have a very interesting dichotomy, I guess, of this spinal cord. We have this cross section as well as the longitudinal section. So here we can see the canalis centralis. We see the darker inner layer here of all of these cells known as the ventricular zone, the larger, lighter area, not as dark as the ventricular zone, but not as dark as the marginal zone either, known as the mantle zone. And then, of course, the marginal zone right here, which is the lighter. You can imagine the term within the margins, which is just the margins of a paper. So the corners of a paper, that would be the outer end. While here we have it in cross section. So we have the ventricular zone here, a lot darker, the mantle zone here, and the marginal zone, as well as the pia mater could also be something that they ask you about. As for the next slide, in this case, it's a separate lung slide. So we write in the developing lung in pseudoglandular stage. That whole name, if you don't write in the word developing or you forget the word pseudoglandular, you won't get the maximal amount of points. And then zooming in, we have some structures here. Now let me go through some structures that they might ask you. First of all, the ones that I asked you about, the dichotomous division, like I said, it looks like a fidget spinner. It has these three sort of outward extensions, so it kind of looks like a three-headed clover or a Mickey Mouse head, whatever description suits you the best. You have that there as well, again almost like a Mercedes, like three-headed arrow, like so. Then you have the blood vessels, which also could be something asked. I don't know if you need to use the word differentiating blood vessel in this case. The professor may ask you to write that down. But here, all of those red blood cells signify where the blood vessels are. All of this tissue that is lighter surrounding those openings is known as the mesenchyme. We have the developing pleura here as well. And then we have these larger openings. I would say maybe if we go back, we have them here known as the developing bronchi. The smaller openings are the developing bronchioles. Let me just turn off my sound. There we go. So again, larger openings, developing bronchi, smaller openings, developing bronchioles, and then these this loose tissue that surrounds these larger sections of the liver is known. The liver, oh my god, the lung is known as the developing pleura, and here we can also see those blood vessels. Yeah, I think that's it. Let's go towards the next slide. Here we can see the developing finger, but trick question, it's upside down. So the nail is actually here. Why do I know that? Well, because we can see that very characteristic nail fold that helps with the developing nail right down there. This is not the nail fold because we can't really see the other structures here. In order for you to identify where the nail is, you need to search for that nail fold that looks like a wart almost, and then also this indent, this U-shaped indent that goes inwards, as well as that flat area where the nail usually sits. Now, if you look up here, we do have a fold here, but we don't have that indent, and nor do we have a flat area towards the top of or the tip of the nail. Some students mistook this as the nail fold, which makes this a very, very skinny top of the finger. So be careful there. Make sure that it's not very huge like this is, and that it has that indent as well. Zooming in, we see that indent, all of that dark area known as the nail matrix, so the developing nail matrix. The lighter area is the developing nail root. And then we have the developing nail bed where the nail sits on. This more pinker or redder area could be the developing nail, but usually we don't really see it in slides like these. Of course, the nail fold as well. They can still ask you about the epidermis, the dermis, the lymphatic vessels here in this slide. They can kind of fool you, make you think that we're looking at the nail structures when they actually zoom into the bottom part of the finger and show you the skin structures instead. It all depends on the mood of the professor. Next up, we have the developing head of the dog embryo. And in this case, the dog embryo usually have these teeth that look like these jagged, almost mountain-like sort of tips, like so, right? We have that developing tongue that I said is very significant for slides like these. Very, very big and important symbol for you to find in order to orientate yourself. We also have the developing eye there. We don't see the lens, but we see the neural retina should be enough for us to identify that. And then we also have the blue area. In this case, they use blue dye that helps us find almost bone-like formations. In this case, it would be the bone trabecula, as well as the developing dentin, which is blue too, in slides like these. Okay, and then zooming in, we're zooming in towards this area. Now here it's a lot more vibrant than what it is here. We can, however, see that sublingual gland at the top right there. We can see the submandibular gland right down there, which is a lot denser, and then also the brown adipose tissue. In this case, I wanted you to have an image where I can show you all three of them. Even though this is a very blurry image, I think it's enough to discern the differences between all of these three. Number one, we have the sublingual glands, and it looks and appears more bluer in comparison with the submandibular gland. It's also closest to the tongue, right? So the sublingual gland closest to the tongue. It appears more lighter and more bluer. It has the same, almost the same color as the brown adipose tissue. Only thing is that the brown adipose tissue miss all of these larger almost ducts in the center. The brown adipose tissue doesn't have that. However, what the brown adipose tissue does have are these lipid inclusions. When they zoom in, it will look a lot like this. Here we go. Zooming in, looking a lot like this, where you can see those lipid inclusion. It will obviously be a lot more blurrier than this because this is a very high quality image. But a good difference between them, as you can see there. Here we can see the sublingual gland from the submandibular gland as well. More of the different. If you want to go through the differences in detail, you can watch the ending of my class 6 video. Continuing on, we have this developing tongue, 11 to 12 weeks. Why? Because we can see the developing papilla right here. It's pretty much rough on the entire surface of the tongue. And hopefully this slide is enough for you to understand that you're looking at the tongue. First of all of those striated skeletal muscle fibers, and then also that rough surface. Sometimes could also be a smooth surface, but I hope that as soon as you see that line with those muscle fibers, you will immediately think of the tongue. And then going further down, we see that. So this is the bottom side of the tongue. We can still see those striated muscle fibers, skeletal muscle fibers, and we can see the oral epithelium here and also over here. Here we have that interlobular duct of the major salivary gland, this being the major salivary gland, or specifically the sublingual gland, which makes sense. It's directly underneath the tongue, so it has to be the sublingual gland. What else do we have here? We have the mesenchyme, which is this tissue that is not the skeletal striated muscle fibers. And then also these blood vessels we can see here as well. Could also be a question asked instead of the duct or the glands, just to check your general knowledge in you being able to distinguish between a gland and a blood vessel. We have these things which kind of look like nerve fiber bundles, but I don't want to venture out to say that. But we do have some nerve fiber bundle in this slide. I just can't find them right here because it's such a light scope. So yeah, I think that's it for this slide. Continuing on, we have this, which is the animal head and sagittal section. I hope it makes sense that this is an animal eye. I mean, look at this size of this lens compared to the rest of the eye. Should sort of be a big tell that we're looking at an animal. I think this is a rat. Also, all of these hair follicles, just a lot of them in the dermis, also is a tell that we're looking at an animal. This is the neural retina, could be something asked. We can also ask you about as if I'm part of the main gang. The professors can also ask you about the vitreous body, as well as the remnants of arteria hyaloidea there. They can ask you about the long lens fibers, as well as the anterior cuboidal epithelium here. I believe this is also the cornea of the eye. So we have the anterior eye chamber. Because this is an animal eye, it looks kind of odd and different. This would be the ciliary body, I believe, or even part of the membrana pupillare. It looks very strange here, though, I must admit. So this would be the entire eyelid, because it's in front of the a cornea like so. Okay, but here we have something more interesting, which is the developing nasal cavity. And the developing nasal cavity, if we zoom in, has the developing nasal mucosa. It also has the nasal cartilaginous capsule. I think that's enough, but like I said, if it looks like these flame-like structures, like so, it's the developing nasal cavity. If it looks like it's just some Wi-Fi signals, like 3 in a row, like so, again, looking like a Wi-Fi signal, it's not this complex with the structure. It's the nasal conches, don't know how to pronounce that. But in this case, this is definitely the nasal cavity because of the more complex structure of it. And it's close to the eye. Also, this is the head. I hope that makes sense. As soon as we see the eye, we know that we're in the head area. So the only real structure that can look like this is the nose. That's it. Let's carry on to the last test, which is the fourth one. Okay, let's start with the final test. First off, we're in this slide. Now we're going towards the top left of the slide. Then towards the right area-ish. So we're seeing this general structure. And we're zooming in, and we see something like this. Please tell me the name of this structure. Alright, let's move on. So we see something like this. And then we go towards a little bit towards the left to see this general area. Now zooming in towards this area, we see something like this. The question is, trying to find a good example of it. What is this, or this even called? These two. Make sure that you're writing down the name of something that is actually on the structure list as well. Trying to find another example. This could be it as well. Okay, next slide. We see something like this. I'm not going to show you anything else though, because I hope this will be enough of a tell of where we are. So zooming in, we see this. So we've zoomed into one of these areas, and I know this is a completely different picture, but this is what we see. Please tell me what this is called. Okay, let's go to the next slide. Here we go. Let's write down the slide name if you know it already. Now we're going towards the bottom part of this slide. Here we go. And tell me, what is this structure called for this slide? All right. Next, we're still within the same slide, but now we're going towards the bottom area. So from this part, we're going further down, we see this. This is where we were at before, if you recognize it. And then zooming in towards this area, we see something like this. So please tell me the name of this structure. If we had zoomed out, it would be this structure. But because we zoomed in, it's now this. Right? Carrying on, we see something like this. And then now we're going towards the left of this slide. And we see something over here. I would like to zoom in towards this general area. And we see something like this. Please tell me the name of this structure. I'm going to show you another example of it, but if you know the name of it already, please write it down. Another example would be this here. Be careful. Okay. Next slide. We see this. Again, going towards the bottom of this slide, we see this. But we're going to focus in on what we see here, and we're going to zoom in. Please tell me the structure of this. Thing. Okay. All right. Moving on. We're looking at this general structure. Now we don't see any other adjacent structure other than these. This is all we see. Just to be fair on you guys. And zooming in, we see something like this. Now please write me the name of this structure. All right. Now we have this slide instead. And we're going to zoom in towards, let's say, we're going towards the bottom area and zooming in. We see something like this. Please write down the name of this structure. Okay, now for the next slide, let me zoom in. This is the final slide of the fourth test. I want to be true to the microscope, so I'm going to zoom in as much as I can. So again, this is what we see, and we're zooming in towards this area, and we see something like this. So again, we see this, but we mostly see this. Please write down the name of this structure. And then if you feel done, feel free to review your answers. We're also going to show you, I'm also going to show you some bonus structures at the bottom. Okay, bonus structures. We're in the same slide as before, but this is what you see in front of you. Please write down the name of this structure as well as this structure. I'm going to give you 30 seconds for that. This and this. Same slide as before, just different area. So again, this one and this one. Okay. All right. Let's go through the answers real quick and then do a thorough deep dive into the answer. 4.1 slide name was the head development of a dog embryo, and the structure was the intramembranous ossification, all of that blue you see on screen. The slide name for 4.2 was developing hand, and the structure was the lymphatic vessel. 4.3 was the embryo in sagittal section. Usually when you see these structures, it's usually in the sagittal section of an embryo. You can see other structures here as well, as including the liver. That's just my general explanation. But they will show you adjacent surrounding structures, not just this image. I just wanted to test you guys by just showing you that area. 4.3 structure was a recanalization of intestines, and we'll explain why. 4.4 was the developing tongue, 6 to 7 weeks specifically, and then the structure was the mesenchyme. 4.5 structure, slide name is the same as before, the developing tongue, 6 to 7 weeks. We didn't really move over from that. And then for the structure was the M. orbicularis oris. 4.6 slide name, total embryo in sagittal section, and the age you can also add in if the professor asks you to. And then for the structure, it was the developing acini, or this developing serous acini. 4.7 slide name, small intestinal development or small intestine development, because it's a separate structure, it's not connected to any other structures. And then 4.7 zoomed in, glandulocyte or goblet cell. I think the goblet cell is more accurate if you're following Professor Vaivad's instructions. Then 4.8 is the developing spinal cord. As for the structure, it was the mantle zone. 4.1 was the developing lung in pseudoglandular stage. And then as for the structure, it was the developing bronchus. 4.10 was the developing head, or developing human embryo brain, sagittal section. And 4.10 is the ear cartilaginous capsule. I think you should also write in developing ear cartilaginous capsule there to be sure. As for the bonus slide, this was the neocortex and this was the developing plexus choroidus. Let me just show you that. There we go. Okay, let's go through the answers real in depth. This is getting to be a long video already, so let's go through these answers a little bit quicker than usual, because these are really repeating answers. For example, this developing dog head in sagittal section. We can see the eyes, we can see the late tooth development, we can also see the tongue. And then here, these are also still late tooth development, but once zooming in, we can see them more clearly here. And surrounding it, like I said, the bone development that we have in the lower jaw, we also have it in the upper jaw here, is either the Meckel's cartilage, but if it looks like this, like a zebra pattern, it's the intramembranous ossification with the individual bone trabecula here. Here the slide name is the developing hand, and then zooming in we can see the skin. It was a little bit hard and difficult to find the lymphatic vessels because this is a blood vessel, because we can see the blood cell. I did show you guys this, but try to skip over this that looked like a blood vessel. It kind of looked like it was going in on itself here, but then I tried to show you guys these instead, which in my head kind of looks like white adipose tissue. So I was a little bit scared that you would write down that instead. So I was trying to show you guys something more elongated. A little bit of a failed mishap on my side, but hopefully you guys got it anyways. Like I said, if it's a blood vessel looking structure with no blood cells, and we're in the database, it's the lymphatic vessel. This would be more of a clear answer, but it's very blurry. Here, I was a little bit evil and I didn't show you any surrounding structures, but we do see the liver here. If you can recognize that tissue, it's definitely the liver. And these intestinal loops, or recanalization of intestinal loops, are very characteristic of the embryo and sagittal section. The only real structure where these intestines are separate is in the small intestine, which we saw later further down. Here, for example, these are separated slides, but when they look like loops, it's usually together with the entire embryo. And then zooming in, don't know what happened here. Okay, we can see that in the middle of these, there is something going on here in the middle, right? See that the lumen isn't completely clear. Then we know it's the recanalization of intestines. If you just wrote in intestinal loop, I'm sure you would get or gain points for that. For example, here, this would be more of an intestinal loop. We don't really see anything going on in the lumen, but here we can definitely see something like very opaque within the lumen of this intestine. So I would write down the recanalization of intestine if it has something going on in the lumen. If not, it's just an intestinal loop. Here we have the developing tongue, 6 to 7 weeks. Why? Because it's a very smooth tongue surface. We don't have those papilla that signify it to be an older tongue. We have those striated skeletal muscle cells at the center of the tongue. And then lower down, here we can see the interlobular duct. We can see small glands of the major salivary glands / sublingual glands. But surrounding it, all of that tissue we see here and here is the mesenchyme. Again, a very simple structure that could still be asked of you. Even here we have these striated skeletal muscle fibers, but in the surrounding them, all of that is the mesenchyme. So again, be careful. We also have the blood vessels here, not to be confused with the glands. Here we have that apoptotic Meckel's cartilage. Why is it Meckel's cartilage? First of all, we're in the lower part of the tongue, i.e. the lower jaw. And if we're in the lower jaw, we either have the bone trabecula, which we can kind of see here, that we went through here, this bone trabecula thing, or we have the apoptotic or non-apoptotic Meckel's cartilage, which is a hyaline cartilage-like structure that is sort of breaking apart. We can see all of those hypertrophic chondrocytes in the center as well. But this, even though it's an important structure, is not what we asked, what I asked of you for this slide. Still could be very important. We have the oral epithelium here, which covers the inside of the mouth. And then further on, we can see this is where the Meckel's cartilage ends. We can see the lower lip. Now again, all of this is the oral epithelium, all of this right here. And then this is the epidermis, developing epidermis. So this is kind of the line of the dry skin side of the lip and the mucus inside of the lip. So oral epithelium here and then epidermis here. Very important distinction. But more importantly, we have this muscle tissue within the lip, known as the M. orbicularis oris. Now this is a zoomed in version, and this is what it could look like under the microscope more zoomed in. That's why I wanted you guys to hopefully get it as soon as I showed you this and then told you that this was a zoomed in version of that. If you can recognize these as muscle cells, you're on a good headspace there. But I went back just to show you what it would look like zoomed out. Again, you could ask your professors to zoom in and zoom out. I believe they would be kind enough to fulfill requests for you regarding, the zoomage of this slide. Here we can also see those lymphatic vessels because they're not, they don't have any blood cells in them, and they're within the dermis of the skin, so they're lymphatic vessels. And then we have a hair follicle there. I think that's all. We also have the dental lamina dentis. There we go. We have the lamina dentis here. We can't really see the early tooth development here. It's cut in a weird way. But again, the lamina dentis is right there. Don't think they would be that mean and ask you for that structure though. Next up, 4.6. This is the developing thymus. Again, a very prominent structure for the embryo and sagittal section. And we have the developing, the developing ribs. There we go. And the intercostal muscles as well. This is the developing heart. And luckily we don't have to know about the structures for the heart for this colloquium. They could still ask you that, but I doubt it. We have the aorta here as well. Then here we have a part of the lung in pseudoglandular stage. This is the diaphragm because it separates, it's a muscle tissue that sort of acts as a wall between the thorax and the abdomen. Then this large structure here, I hope is easily recognizable as the liver. And then we have the, I would say these are recanalization of intestines as well, because it has all of this going on in the lumen. But this tissue right here is known as the pancreas. Now if we zoom in further, we can see here this being the liver, this being those recanalizations of intestines, and then this is the pancreas. And within the pancreas we have these serous structures known as the serous acini, or developing acini. Developing serous acini works as well. I believe that would be a blood vessel, but it's too hard to tell. So again, if you see the liver, know that they could also ask you about the pancreas as well, which is close to the liver. The liver being a lot darker than the pancreas being a lot red, I would say, a lot more red. And then also the liver having these hematopoietic islands, which the pancreas does not have. Then we have the small intestine development, and here we can see all of those this recanalization happening for the intestine or the villi. Maybe it's not even a recanalization occurring, maybe it's just the villi being cut in a weird way. But here they can ask you about the muscularis externa, including the inner and outer, I would say circular layer, the tunica serosa, and the submucosa, as well as the villi itself. But, so this being a lip villi, but they could also ask you about the goblet cell or glandulocyte, different name depending on the professor. I know that my professor wouldn't have accepted goblet cell as an answer from asking. But yeah, then we have the enterocyte, as well as this whole section being the simple columnar epithelium. To be clear, goblet cell is accepted by Professor Vaivads. Okay, here we have the developing spinal cord. We have the pia mater here at the corner, the marginal zone, the mantle zone that I was asking about, this being mantle zone as well as this, and then the ventricular zone, which is this darker area, as well as the canalis centralis in the middle. This is a separate slide. We do see some developing vertebral column going on, as well as the spinal ganglion, the developing spinal ganglion. But all in all, it's a separate slide, so it's enough to write in the developing spinal cord, I would say. Next up, developing lung in pseudoglandular stage. And like I said here, we can zoom in. We can kind of see the developing pleura, not really. These are bronchioles, these small ones. These larger ones are known as the developing bronchus. These are the dichotomous division because they look like fidget spinner. Trying to find another example of one here as well. This one. And maybe this thing as well. They make it a lot more clear for you in the colloquium. We have the mesenchyme, which is this tissue in between all of these bronchi and bronchioles. We have some blood vessels here as well. I know that Professor Vaivads asks you to differentiate a vein from a artery, or a muscle type vein from a muscle type artery. You could check my previous video for that. Class 5 video for that. And yeah, that's it for the lung. Now 4.10, we have the head or brain development in sagittal section. The eye here being the most important signifier. We can see the inner ear development, and we can see the lamina quadrigemina, the pons, as well as the medulla oblongata and plexus choroideus here. But more importantly, this was in focus, and therefore here we can see the corner of the pons as well. But instead, I asked you about this section of the inner ear, and that is known as the ear cartilaginous capsule, or developing ear cartilaginous capsule. These openings depends on what the professor thinks, but I would go with the developing cochlea just to be on the safe side. You could also make a point that these are semicircular canals. Maybe not, actually. Developing cochlea is just fine, I would say. Okay. And then finally, for the bonus slide, we're in the same area as we were here, but I wanted to mention or to bring up the neocortex as well as the plexus choroideus, because those are still important structures for this colloq, and we kind of missed out. Another important structure is the chondrocranium, which we didn't go through. You can find it both in these sagittal section of the head, like something like this, or in the brain development here. For example, this is more of the chondrocranium, this right here. There we go. This being the orbital bone. Here we have the desmocranium, and then the chondrocranium right here on the back. Okay, that was all for this test. There are a lot of structures I haven't covered. Where are we? Okay, we went through this. Oh, thank God. I thought I missed some. Here are some structures. The ones in red I haven't covered. The ones in black I have in this test. So you can just see how much I really haven't covered. These are not all of the structures in your structure list. These are just all of the structures that I've gone through in detail during my videos. So for the last time, double check with your professors, double check with your list of structures. However, for me, these was enough to gain a lot of points during the practical part of the colloquium. You can find this document in the video description. And yeah, that was it for the embryology videos. And I hope you guys have a good time with the final colloquium in embryology. And yeah, good luck, guys.